Eric! Thank you. Now, KJ. You're confusing me. KJ. Now, in the previous lesson we were looking at this rule called first principles. The problem with this rule is it's kind of long. Takes a while to do. So now, we would like to know, is there a faster way? And there is. We can find the derivative by rules. So rather than using first principle each and every time, what we'll do now is we'll look at some general form. Like, for example, what if I have a function like xn? So I have something like xn. If I can get an answer here, then I can use my answer any time I have xn. I don't have to use first principles again. I can just use my answer from this problem. But now we have to first find the answer for this. So that's what we'll start with. Okay. So please write this down carefully. Does the heater go back on? No, okay. It just feels warmer. I think I need to turn the other one off. There we go. Okay. As I was saying, delta y over delta x. Let's see what that is. So on the top, I have x plus h power n minus xn over h. Yeah? Now, what can I do, or what can I use to simplify the top? Yeah, but what's the name of the lesson? What can I do to the top? No, come on.
I know.
Well, tell me, Jerry. What do I do? No, Jerry, I want to know what to do. What? Did he just say molecular chemistry? I don't think I can use molecule chemistry here, Jerry. What can I do? Does anyone know? Expand how, though? I can't use Pascal's triangle because I don't know what the n is. So I can expand using the other method. Binomial coefficient. So this will be nc0. And I think I'll start with the x first. So xn h0. Yeah. nc1. Yeah. And minus 1 h1. And then this continues. Yeah. H squared. Very. Right. This continues, and then at the very back we have minus xn, which was from this one. Now, if we look at the top, at least two things can cancel. What two things cancel? Well, this here is actually, what is this equal to here? If you look at it, H0 is 1, so that's gone. MC0?
1.
Xn can cancel this one. So that goes with that. Yeah. And if you look at now what happens next with the H. H power 1 divided by H. 1. H squared divided by H. So this is H, yeah?
So H's go with H?
Yeah. Each time it goes with the H, yeah. So H goes with H1, h squared goes with the h, makes h. The next one would have h cubed in it, but because I divide by h, it becomes h squared. So, what you're left with is this. nc1 xn minus 1 plus nc2 xn minus 2h. Yeah, that's what we're going to get to next, yeah. And this continues, etc. Now we know, as you said, Monica, nc1 we know is n. Is n. Yeah. All the other parts, I actually don't care what they are. I just care that they all have h in it. And when h goes to 0, they're all 0 anyways. So, we now have our first result. If y equals xn, then that means the derivative is equal to nx n minus 1. Please write this down carefully. Hanukkah, can you make my handwriting out? Is it okay? You don't need to sit nearer to the front? No. Because I know my handwriting's so bad. So bad.
Mine's
Yeah, yours is fine. Yeah. You're perfect, Jerry. Okay. Can I scroll down? Yes?
No.
Not yet? Okay. Some of you have probably seen this rule before. Yes. It's useful. It's actually bad grammar, but because it's being used so much, it's now normal. I wouldn't call Justin Timberlake culture, because he was the one who wrote the song for McDonald's for that catchphrase. So, like I said, Lee, I wouldn't call that culture. He's quite old, yeah. It's like some 1990s.
Maybe Jerry don't know him.
It's possible, yeah.
Jerry, you know Justin Timberlake?
Okay, do you have that now? Yeah? Alright. Now, what does this result tell me? Well, it means that if we think back to the last lesson, if I had x squared, I can know the answer automatically. The derivative will be 2x1, or in other words, 2x. Likewise, if I have x cubed, the answer will be 2x squared. And so on, and so on, and so on, like this. Now, actually, if you had something like this, a 7.
0.
Yeah, but you can get it by using this rule. Because if you think about it, 7 is like...
0.
Yeah, 7x0. Which becomes 7... Focus. Jerry, don't distract me, please. Which becomes 7, 0, x, and what's up here?
Minus 1.
Basically, the rule is you take your power, you bring it down into the front, and then minus 1 on the power. This is the basic idea behind this rule. We actually have many rules like this which will be convenient. It's not necessary for me to prove all the rules, just to prove this rule. I will give you the results for the other rules. So if you have a function like sine x, yeah, its derivative is, well, some people know this. Which is it? Cos x. Cos x. If you have cos x, its derivative is minus sine x. Log x. Now, if you want to know where I'm getting these from, you can find these using the first principles rule. 1 over x. Tan x. Good guess though. One over cos squared x. Ex. And actually, if it was Eax, it's still Eax, but there's an A in the front. Or maybe I'll use a different letter, I'll use N. It doesn't matter, you can use A if you want. Enx is Nenx. Let's use this rule again, but for something we know the answer to show you how quick it can be. But first, you should write this table down. This table is important. Okay? There's 1, 2, 3, 4, 5, 6 rules in this. Do you have those 6 rules? Yeah? Okay, so earlier we did this example. We had we had root x, and what did we say its derivative was? 1 over 2 root x. Let's try this by using the rules we have. Yeah, so the first thing we have to do before we start is we need to change this into x power a half. Yeah. Now we can use our rule. The rule says in the table, bring down the power. Guys, come on, focus. Bring down the power and then minus 1. So it would be minus 1 over 2. But this is the same thing as 1 over 2 root x. Same answer, but much quicker, of course. You can do it this way in the exam unless the question says use first principles. Then you can't. You must do it the other way. But usually they don't care which way you do it. You can do it this way. And you should do it this way because it's quicker. Yeah? Let me give you one to try. Can I scroll down a little bit here? Try this one. We'll say y equals, let's make it interesting. X plus 1 over root x plus e2x. No, oh yeah, okay, sorry. I was going to make it harder. We'll try this one to start with. I want dy dx. Give me the derivative here. Okay. How do we feel about this? We got answers? So the first thing I should do is I should change this into x1 plus x a half plus e2x. According to my rules, this will become 1x0. And this will become a half x minus a half.
No. 3 over 2. X power minus power.
No. Minus 1. No.
Oh, sorry. Now I understand. The word initially gave it away. Thank you. Sorry. My mistake was back on this line. I should have said minus. So this will be...
Minus 3 over 2.
Let me fix it. Minus. Okay. Yes, this will be minus 3 over 2. And then this one... 2x. So finally the answer is 1 over 2 square root x cubed plus 2e2x.
Yeah.
Okay. Right, let me give you a harder one now. Really get you thinking. Can I scroll down?
Yeah.
Okay, I'll give you okay, no, I'll give you, rather than one hard one, I'll give you 2 medium ones. Okay, so the first one is this. Root EX. Try that one. Okay, do we have answers?
Yes.
So, what should I do first? Change this to EX power a half, yeah, and then change that into E power a half X. Now I can use the rule.
Yeah.
A half E a half X. That's it. Because this, in the rule I gave you, E n X becomes n E n X. And this is the n. Okay, try this one now. Y equals log 2 x cubed. Okay, now I'll make it easier. 2x. Got an answer? What's your answer? No, don't be shy. What's your answer? That is wrong. What did you say? At the back? Go on, don't be shy. What's the answer? That is wrong. 1 over x? That is right. Yes. The answer is actually 1 over x. And let me show you. You cannot use the rule. Because if you look at the rule I gave you, the rule was for what? Log x. This is log 2x. So first what you should do is change this into log 2 plus log x. Using the first rule of logs. First rule of logs. Now we can differentiate. This becomes 1 over x, and this becomes 0. Because it's just a constant. It's like the example I did earlier, the number 7. What's the derivative of the number 7? It's 0. This basically becomes 0 because there is no x. Yes? So the answer is 1 over x. Yep.
What if it was Q?
Well, let's do that now. Okay, try y equals log 2x cubed. Now we can try this one. That is the very first thing we should do is split this into log 2 plus log x cubed, and then we can split this into log 2 plus 3 log x, and this becomes 3 times 1 over x. So 3 over x is the answer here. So for example, I'm not quite sure what the graph is, but it'll look something like this. At the point, for example, 3, what will be the slope of the tangent here? It'd be 1, because I just put x as 3 as an example here. Yeah. Now, as the x gets bigger, what's happening to the slope here? It's getting smaller. So the graph is actually kind of flattening, kind of not as steep. It's getting flat. Okay, can I scroll down? Yeah. Okay, let's see. Now, a hard one. No. A really hard one. I'm thinking. Relax, I'm thinking. No, that's too hard. I was going to do a big one, but it's too hard. Okay, let's try something else. Right, try this one here. Log sine 3 plus root 2 plus cube root tan 1 over cos 2. Close. Cos 2. Just wait how long it takes for other people to realise though.
Bracket mistake.
Which bracket did I miss?
Second.
Sorry, this is
No.
this is in the tan. That's fixed now, yeah?
Sine.
What's wrong with my sign?
Sine plus root 2.
Yeah.
Bracket.
No, this is fine. That's plus. Right, what's the answer here? 0, yes.
Why? No act.
Good, yeah? No. Did you like that? It was good. What's wrong? Eric?
Nothing.
Are you sure?
No.
You sound very angry. Did you get 0?
Yeah.
Are you sure?
Yeah.
Okay.
Let's change the 3 to the accent.
No, let's not do that. Can I have a look at the questions there to see what else we have? Now, just before I let you try these, guys! No, before I try, let me show you something here. I just want to show you the different ways. God. Listen. I just want to show you the different ways to write derivative, okay? So, you could say, for example, y equals x squared, what's dy dx? You could say y equals x squared, you could say fx equals x squared, what's f prime x? It means the same thing, okay? You could also say what is d dx of x squared? And you can also say x squared with a little dash here. These all mean the same thing. The answer is 2x, the answer is 2x, 2x. Okay, these are different ways to write the same thing. What is the derivative of x squared? Please make note of that, because in the exam you don't know which one they'll use. Yeah, that guy. Whoever it is, he likes to ask questions that have not come up on the exam before. Oh, very. Smart too.
Yeah. I was going to.
Yeah. Okay, do you have that? Alright, let me tell you which ones to try. Sorry, I'll just double check. Yeah. No, yeah, but the business students don't.
Maybe just for that. Just for that.
Oh, that's right.
No.
Just maybe just specific. Yeah, just under.
Okay, so I want you to try, and you can look, Jerry. I'll give you the questions, and if you get them finished now, then there's no homework. So rather than blah 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 blah, if you do your math quickly, you have no homework then. Okay?
Okay.
These are quick questions, aren't they?
Very.
How long will it take to do one question? Now be realistic. How many seconds? How many, guys, how long would it take to do one question? Seriously, how many seconds? 10 seconds.
No, it's not. 2 minutes.
So if I give you 26 questions, it should take you only like 5 minutes. Do question 2.
Which one?
All of 2.
Now one.
Which is the hot one?
Hang on, let me, so, I hear this, Christy.
Which page?
Okay. I should go home now.
Question 2. All the questions.
Which page?
The next page.
Eight done?
What? Yeah,
It's not true.
it is true. Question 2, all of it. Come on.
Oh my God.
Give up.
Come on.
Let's think of a pretty question.
Christy, come on, let's talk in more differentiation.